Hello, and today we're going to be talking about things that are involving references. And references are usually sandwiched between the teaching of like methods and functions and arrays, because as you'll see, they're kind of vital to both. But before we dive into using them, why don't we back up a little bit and just try to discuss what they are. So up till now, we've kind of been thinking about variables as values. So I'm going to double click into here. And we usually have to set up our variable for something. And this is going to be a real simple program. Don't worry about setting it up yet. We'll talk about it in a second, because what I want to do is kind of establish the language here. So we have a data type followed by a variable name, and then we're instantiating it with a value, and that value is 0. So we tend to think of x as 0. But think of driving your car to a parking spot. Then let's say you're going to the mall, you're going to a sporting event, anywhere where you have to remember where your parking spot was. The car is actually the value, if that makes sense. And then we have the parking space, which is kind of the reference. So in other words, if I were to say who's in spot A10 and it's a Cadillac Escalade, we have to refer to the Cadillac Escalade through the parking spot. But that Cadillac Escalade could move, right? The Cadillac could move, and therefore that's the same as if the value changed. But unfortunately, the parking spot can't actually move. It's going to be A10 or D55 or S117. It's stuck with that same number in that same space. Now translate this into the computer world. On a memory stick, let's say you have 4 gigs of memory or 16 gigs of memory, whatever, somewhere on there, there's a physical location where data is going to go and be temporarily stored. And you can kind of think of these things as large parking spots or very, very small parking spots, whichever way you want to think about it, depending on talking about, in gigabytes or size, physical size. So values have to go into those physical spots in the memory. They're literally something that's magnetically flipped over in the memory, and you can store value in some part of it, and that physical location is not going to change. Well, that's all that we're saying here, is that somewhere in the memory right now stores the variable name x and says there's a 0 inside of it. And likewise, if you look at the next line, line 23, there's the variable y and the value 5 inside it, all in some memory address. Now, when we talk about these values, we can find them by finding the parking spot, right, or the place in the memory card, whichever analogy you want to work here. But what becomes interesting is what can we do with them later? Because now I'm going to come down to a method where we have another x and another y. Right? So in this case, if you guys remember, what we're saying here is int x is equal to SubButton tab, put SubButton's x value. So it can be changed, and in fact, as you can see, it changes it into 17. So we really are creating 2 variables, and these 2 variables are going to be in 2 different parking spots or 2 different places on the memory card. But that sometimes can create a little bit of redundancy. Right now we've created 2 different variables taking up twice as much space and it taking twice as much time to get the values back if we want to refer or grab both of their values. And before I forget, I'm going to delete this back so that we run well. So there, in the computer world, they said, well, why can't we just pass the reference value, making this x equal to this x? Or when I change this x, it refers back to this parking spot and putting a new car in that parking spot. So let's kind of wrap this up before we start playing with this. A reference variable doesn't actually hold any data or value. It simply refers to a spot, whereas a value holds no permanent spot on the memory card. And therefore, the reference has to link that value to a specific variable. A little confusing, I know, but let's play with this a little and see what happens. So the first thing that we're going to show you, and I am going to, believe it or not, get rid of this. So, well, let's start you off here. This is real simple. I have a x value here, and as you can see, it's xval is the actual name. And then we have a reference value, which we're going to call refval. And then a submit button to make everything go. So we're going to work everything through the submit button, and we're going to just change. We're going to change these labels. Now clicking into the submit button. Oh, and I forgot to tell you the submit button was called SubButton. Again, a little naming convention, maybe a little off, but we'll work with it. At first, what I'm going to just want to do is, I think I will stick this. So int x equals 0. We're going to declare and initialize it. Same with the y. We're going to spit out the x value here. And remember, we have to take x and turn it into a string. And then we're going to call on x find value xy. And I'm going to use this again in future use. So I have it returning x to us. But what we're really worried about is this xval text, and which was up here, and then the refval text, which we are going to say is right here, refval.text is going to equal, and let's just put that down here. So we're going to grab this x now. So hopefully the first one is going to be equal 0 and the second one is going to be equal to 17. But we should put ref value, even though technically it isn't. Or we'll call it find value, right? For find value being the method name. And now if we start this up and I hit the submit button, 1 is equal to 0 and 1 is equal to 17. Okay, let's run this again, but now I'm going to move this line down. And then I want to make one more change. I'm going to actually change this to y. As you can see, y we're not using here, but I'm just using it as a dummy label so I can mess with x more. So now when I hit start and I hit submit, xval is 0 and xval inside of find value is equal to 17. Everything seems kosher. Now let's actually add the reference in here because we have no references. So how do you add a reference? Well, it's really simple. All you have to type in is ref. For all you C++ fans, I know you're missing the ampersand there, but it works the same exact way. So what I'm going to do is put reference here and say the reference of this x is going to be the same as reference of this x. Now in this case, now they're going to the same parking spot here. So when this is x is equal to 0, it's going to pass 0, not 0, but where x is, and says, okay, where is x? Okay, let's say it's at A10 again. So it's saying A10, and I'm going to put A10, and then it's going to say change at A10 0 to 17. And then we're going to get out of here, and we're going to return x, but we don't have to worry about that. But now let's see what the difference is. So when I hit submit, now both of these are 17 because I've changed the value in find value, but since they're sharing the same spot, since the x in find value is at the same, or looking at the same spot in the memory as the x from SubButton, they have to be the same. Whatever in that spot, you know, whatever in A10, so to speak, is going to be the value for each. And likewise, if I changed the x, say, in the SubButton click and passed it in, then all of a sudden it would change it to, it would change the x for all the program. So in some ways, this is a way to get away from the scopes too. So in other words, remember back when we talked about encapsulation, where we try to keep everything that's in the curly brackets to stay inside the curly brackets. Here, this allows us to go outside the curly brackets with x and put it into another scope. And that's basically it. Now, what's the advantages for it? My favorite part of it is just speed. You're speeding things up. The less you copy, the quicker you do. The less memory you use, and using up memory is important. It also simplifies. But let's try to practice some of these in some of our other exercises.